All right, in this video, let's talk about the general anatomy of a skeletal muscle first, and then we'll go on to connective tissue. So, again, we're going to spend most of our time on skeletal muscles themselves, revolving around skeletal muscle tissue. So, let's take a look at a drawing of a typical skeletal muscle, and you guys know I don't draw real well, but all muscles in some way, small, large, skinny, you name it, they all generally expand slightly in the center. So I'm going to draw a center line right here. And this expanded central part of the muscle is called the belly. And then you can see at both ends the muscle is going to taper into connective tissue. So let me just kind of make like a little indentation or in some type of, so we're changing, and it's inherent tissue. They're joined together, but it's going to change from muscle tissue. So I'll put some fibers in here, make it look like a big onion. And then it's going to taper to a different type of tissue on the end. This, at each end, and you would have guessed this in class, is called a tendon. Now, generally speaking, those tendons attach to bone, but it could also be other muscles and or soft tissue. Isolated cases, but it can happen. Okay, hopefully you wrote that down, because I didn't write that down. We'll practice college stuff here. Now, sometimes the tendon the muscle will taper into a tendon. So let me do it right here, just a smaller version. So we have a muscle tapering right here. And then sometimes that tendon is going to go like this, and it's going to expand. Okay? Anytime that tendon flattens out or broadens, I think that's a word, if it's not. If that tendon is not tapered and skinny like it is in this drawing up here, if it looks more like this in any way, that tendon is then called an aponeurosis. Oops, N-E-U, neurosis. That's N-E-U. An aponeurosis. Here, let me write that one more time so it's clear. I'm going to make mistakes. You guys know that. So that's a broad, flat tendon, an aponeurosis. Now, what's the advantage to that? Anybody want to guess? I can hear you talking to me. You guys know it's going to increase, wait for it, surface area. And if it does that, what does it increase? Well, if you look at the biomechanics of muscles and bones working together, it's going to increase the big L. Anybody want to take a guess at the L? I heard you. It's leverage. And if you increase the leverage of any attachment to a skeletal muscle, what else do you increase proportionately based on design? Well, let me guess, power. So with these broad, flat tendons in some locations on your body, you can actually increase the power of a muscle even though it may not be that big. And that saves time, energy, and space, all good things. So that's just like a basic overview of the anatomy. Now let's get to the tough one, okay? And you're going to have to follow along, but you can always rewind this if you want. All right, I'm going to start, let me start over here in the corner, and I don't draw very well. Whoops, this should be rounded. Okay, that's a cutaway. This is a bone. Any bone, could be anything, could be any shape, doesn't matter. Now over here, what I'm going to do is I'm going to draw the outside of a skeletal muscle. Now, so that you know what we did here, I took a muscle and I cut it in half, cross section, at the belly, and then turn that muscle on end so that you're looking right down the core of it, okay? And then we're going to actually cheat and kind of look at it microscopically. Now, the muscle itself, from instruction 3 minutes ago, is going to taper and then attach to a bone. So if you look at the bony attachment in this area right here, that's going to represent the tendon. And then I'll kind of do a little rough cutaway. Covering that tendon and leading up and over the muscle, once you come off the bone, that is something called deep fascia. You guys know that's the connective tissue that separates and covers all the structures in your body. And we were dissecting your cat. Some of that superficial fascia was that real loose stuff, but there's deep fascia actually connected and surrounding the muscle. Now, once you get past that deep fascia and you get underneath there, you're going to run into the skeletal muscle itself. There's the skeletal muscle. Now, once you peel away all of the regular connective tissue, there are 3 main layers of connective tissue. I'm going to write them up here. We have the epimysium, the paramysium, and the endomysium. And there is going to be a fourth, but I don't really count it as connective tissue because when you're going to see it's something else. Now this mysium, anytime you see this always refers to muscle tissue. And you guys know that's on top of, that's in the middle, and that's on the inside. So we have 3 layers of connective tissue, which are going to be critically important because muscles, one, have to slide past each other, and then functional units inside the muscle also have to be able to slide past each other because they won't all be contracting at the same time. If they did that, your movements would be like real jerky, kind of like me writing most of the time. So what we're going to do is take a look for these 3 as they come up, and we're going to place them appropriately in the drawing, and then we'll take a look at some other microscopic structural design here. Now, on the entire outside of the belly of the muscle is this outer connective tissue called the epimysium. And if you want to look at that in more detail, you can just kind of look that up on the internet. So that's surrounding the entire muscle, the whole thing. Now, when you dive into this muscle microscopically and functionally, because you have to have control, and keep that in mind as we go, this muscle is going to be subdivided into functional units. And it doesn't matter how many you draw in here. And obviously in a larger muscle, there'd be way more than this. Okay? These individual functional units that I just subdivided in the whole muscle, one of these is called a fascicle. And each fascicle is separated from all of the other fascicles so that they can move independently by something called the perimysium. So you can see we're taking these words and we're kind of blending them on here. So that's level 2. We have the outside as the epimysium, and then each one of these fascicles has a layer of connective tissue called the perimysium. Now the subdivision is going to continue, so this is where you might want to rewind a few times and keep watching this. Okay? Inside a fascicle are individual functional units. I'm not going to draw in all of these fascicles. You guys can kind of add your own drawing if you want. And they don't have to be perfectly round, although they pretty much are. Now, those individual segments in a fascicle, those are actually called muscle fibers. So if you've ever had a really good piece of roast beef that was in the crock pot on low for about 8 hours, and your mom had potatoes and carrots and onions and gravy and butter bread and corn, oh my. When you look at those real stringy pieces, when meat is falling apart, what's happened is through the slow cooking process, you've actually removed or broken down all of this connective tissue so that these muscle fibers actually peel apart in your roast beef. Not that that's a definite, accurate review, but you get my point. Those individual fibers are the functional units inside of a fascicle. So we have a fascicle here, and then it's subdivided into further functional units called muscle fibers. And these fibers are actually the cells of this organ. They're the cells that make up the tissue that make up the organ. Okay? Now, so that these muscle fibers can act independently and slide past each other when they're contracting, there's another layer of connective tissue that separates every fiber from all of the other fibers so that they can act, again, I don't mean to be redundant, but independently of one another, and that's going to be this last type of connective tissue called the endomysium. So that's the basic setup, but there's more for a small fee and no shipping cost. No, I'm just kidding. So what I'm going to do is I'm going to take this one. Let me draw this one again. Just the same kind of thing, and then you can apply this. Now, I'm going to put a dotted line around this one. And then what I'm going to do is I'm just going to draw this one fascicle real big. That's going to allow us to take a detailed look. So that is one fascicle right there. Now, inside of that fascicle, I'm going to draw these guys bigger. And then we'll relabel some parts, and then you guys can make a comparison between them. Oh, look at this. It's almost like we're in school, isn't it? Isn't that nice? Okay. Oh, yeah, you can see that's perfect. All right, so what's the connective tissue surrounding the fascicle? So let's just go up here. Here's the fascicle, and then the connective tissue on the outside is called the perimysium. Okay, and then each one of these individual functional units right here, this is called a muscle fiber, or the cell. And I don't mean to be redundant. I just want you to have a visual connector so you can kind of put this together. Okay? And then each one of those muscle fibers is separated, and I'll kind of trace it. All this connective tissue running inside this fascicle and separating the fibers is called the endomysium. So that's the inside connective tissue in a muscle. Now, this is the part where there's actually more, because a muscle fiber is actually subdivided into functional units. So I'm going to draw those in there. So it's kind of like chocolate chip cookies inside of chocolate chip cookies inside of, you guessed it, chocolate chip cookies. So an individual muscle fiber, the cell itself, is subdivided into something called, oh, that's not correct, called myofibrils. Myofibrils. Now, when you look at this muscle fiber itself, when you look right here, it has muscle fibers inside, but it has this stuff around it. So here's the endomysium, but what is this around each fiber? That's called the sarcolemma. Save some space here for me. Whoops, sarcolemma, that's 2 M's, sarcolemma. Now, the sarcolemma is technically, this is why I don't like to include it as connective tissue, because it's not. This is actually the plasma membrane of the cell called a muscle fiber. So what does this thing do? It actually regulates flow of materials in and out of the cell. So it does, the sarcolemma does what the plasma membrane does for any cell. The only difference in a skeletal muscle is that it's not an individual cell. Remember, in skeletal muscle, we had the fusion. Go back in your notes and look at this. We had the fusion of individual cells during embryonic development so that one cell in a muscle runs the full length. That's why they call it the sarcolemma and give it a special name. Now, let's talk about these myofibrils, these individual functional units of the muscle fiber itself. Inside of there, just put some dots. There's stuff in there. Another level of subdivision. I know it's crazy. Inside of a myofibril are the actual filaments. And these are protein. And those you should already know. Does anybody know what are the 2 proteins in a muscle fiber or in a myofibril? What are the, oh, wait, I know them. So do you. Actin and myosin. And why are those important? Why are those so significant in this review? Well, those are the proteins that are actually responsible for contraction. And as a result, creates the magic of not only muscle tissue, but specifically in this example, skeletal muscles. If you have any questions, I'll put a little thing on our feed, on our stream, so we can ask questions together as a class, and we can, throw some ideas back and forth. But I'll tell you what, just so you know it's me. Hey! Hope you guys are doing all right at home. If you're wondering why my hoodie's up, 2, I love Jawas, and it's cold in my basement. So I'll see you next time. Hope you guys are doing all right. Take care.